Hello everyone! This video will be about my DIY CNC, how I built it, a little walk around, and finally a few suggestions what I would have changed if I were building it right now from scratch. The design is based on Good Enough CNC project. On this page they have all the instructions and a link to the GitHub repository with CAD files. Very nice! I've made some changes to the axis and other components, mostly to reduce the cost. The mechanics of the CNC is quite simple. It is somehow similar to the designs of old CNC plasma cutters. There is a trolley made from a square tube, and inside of it there are ball bearings arranged to slide over the smaller square tube. The stepper motor is attached to the side of the trolley, and it has a pulley that rides over a timing belt. Some templates are needed to make this trolley. In the instructions they used laser cut plywood, but I didn't have access to such equipment, so I've 3D printed a template. A lot of super glue was used to make it more rigid. The template slides over the square tube. This side has a big burr after cutting. Let's try the opposite side. After fixing the template to the tube with some clamps, I can mark drill holes. Following instructions, I assembled 3 trolleys and prepared square tubes that go inside of them. I gathered all required bolts and nuts in this box and 3D printed some parts. Here I pre-assembled the frame to see how it will look and move. Of course, it won't be very convenient to have a CNC on the floor, so at that moment I started to work on the table. For the table legs, I've welded and painted 2 of those bridge-like shapes from old industrial shelving. They even have adjustable bolts for legs. Also, I've cut to the size and painted those cross members. The table is assembled with M8 bolts and nuts. It could be disassembled if needed. I put 2 trolleys on. It will be my Y-axis. Here you can see how the trolley sits on the tube. I assembled my X-axis, and you can see how the belt is going through the trolley. Moving on to the axis, I've printed a template on paper for labels. Laser printers are very accurate nowadays. The dimensions are spot on. I'm using a broken PCB drill that I sharpened to a fine point as a center punch. Here is my Z-axis complete. I wired everything to a simple 5-axis breakout board and stepper drivers and dry run the machine. After some experiments with the Z-axis motor, I decided to replace this puny NEMA 17 stepper with NEMA 23 stepper motor. And here are the latest additions. I surrounded the table with clear polyethylene to prevent chips from flying everywhere. I hanged this film using magnets. Some of them are from hard drives. The 1.5 kW spindle is water cooled. I'll show where blue water cooling tubes and cables go. I also welded this stand from old industrial shelving. The coolant tank is located on the bottom of the stand. This coolant tank started its life as a part of an old washing machine. It's made from stainless steel and ideal for such application. I am using diluted propylene glycol as a coolant. It's very safe, it won't freeze, and it will keep parts of the cooling loop from rusting. The controller box and PC located above the coolant tank. I've made removable screens for fans. There is another one like this one in the front of the box. Here is what it looks like inside of my control box. The power supply is on the bottom of the case. Inverter on the left and breakout board with stepper drivers is on the right. As a computer, I'm using a very old HP small form factor PC. It gives a very good real-time performance. The computer didn't want to boot with DVD drive in it. It was broken. I removed DVD drive and added a SSD disk, and now it works. The wooden table rests on these cross members that I've bolted to the legs. The surface on the table has deviation less than 0.7 mm in the axis. It's good enough, but I'm not sure how long it can hold the shape. It's wood we are talking after all. It really does help to have a cyclone vacuum to clean everything from chips. I have bought a cyclone attachment, and in conjunction with this old vacuum it works really good. Alright, some suggestions for improvement. It would be beneficial to use thicker tubes. All these tubes have a 3 mm thick walls. It's okay, but I would like it to be at least 4 or 5 mm. Also, they are just irregular square tubes and are not precise at all. If you can somehow machine them flat, do it. My 3D printed cable chain was too small to fit water cooling lines. I have used loose cable ties to attach those tubes to existing cable chain. Not ideal, but it works. Next, don't use linear bearings for the axis. My Z-axis is quite heavy and the balls from the bearings started to make small grooves in rods. Also, I have used trapezoidal screw, but it's too small. No doubt it will wear over time. Ball screw is preferred for such application. And that's it. Hope you learned something, see you later, and thanks for watching.